Hello, here we are with part two. We're getting started with uh, speed. So speed is equal to distance over time. I've got a little note for you here. Don't forget to look at your formula chart, which is going to be in your test booklet. Do not try to memorize this, although if you did memorize it, that's great, but you don't have to. So here, remember to write, to show your work, right? You're going to get your calculator. You're going to be able to use that. But when I say show your work, I mean show your setup because people get confused and I do not want you making any silly mistakes. Okay, so I'm going to go through these other three examples that we've got here. So here, they're not telling me to convert anything. So I'm just going to straight up do whatever they ask me to do. So here I've got 100 meters. I'm writing down my unit so that way I don't get confused later, divided by 20 seconds, right? So there's my distance and there's my time and I'm dividing them and I'll let you figure out the answer. The next one I have 1627 miles divided by 4 hours and I'm going to let you get your answer there. Same thing here, 100 yards divided by 25 seconds. Okay, and you can get your answer from there. So here we will have to convert. So this is going to be a really big deal. This is going to totally change our answers. So here, I've already done this for you. This was pretty straightforward, right? 60 minutes in 1 hour. So 30 minutes is 0.5 hours, right? 60 minutes is 1 hour and so on. So let's do these practice ones here. So here I've got 20 kilometers, but the 30 minutes, like they said up here, I want to convert, so I'm going to have 0.5 hours is 30 minutes. It's the same thing, right? Make sure that you understand that there's a big difference between 0.5 and 0.05, right? This is not half an hour. That's like comparing 50 cents to 5 cents, right? So you can figure out your answer there. And then the next one, I have 10 kilometers, and then again, 30 minutes, convert it to hours. So I've got 0.5 hours. And then here I've got 15 kilometers divided by 0.5 hours as well. So you figure out your answers here, use your calculator to finish that. Then I've got force at the bottom. Force is a push or a pull, right? Anything that puts something in motion is going to be a force. And so you could draw a picture of a box moving here, and I could say, oh, that's 10 newtons of force that's moving the box there. Then I've got graphing. So always remember you read these like a story. Okay, so here I've got my x-axis is time, my y-axis is speed. So always check to see what your axis is so you know what's happening in the story. So as time is going, what's happening to my speed. So here we've got it going up like this, and that means that my speed is increasing at a constant rate. And that what that means is that it's going like by fives. So 5 miles per hour, 10, 15, 20, 25, and so on. It's at a constant rate. That's why I ended up with a straight line here, okay? Then the next one, I have a line going straight across like this. So that means that my speed remains constant. In other words, as time is passing, right, my speed is the same. Next one, my speed is increasing here. So here, as I'm going up, I'm getting faster, 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 faster. And it's not at a constant rate like the first one. The first one, I was going by fives or whatever you want to imagine. This one's going faster, 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 faster. Finally, I have my speed increasing and then decreasing. And so I'm getting faster, faster, faster as I go up, and then I start to slow down. It's like I'm getting to a stop sign. I speed up right until I start getting closer to the stop sign, and then I start slowing down, so I stop at the stop sign. Here you've got different kinds of graphs. So for the very first one, you have a pie graph, or sometimes it's also called a circle graph. So here, not only can you compare the parts to each other, like I can say, well, the gymnastics part is almost the same as the tennis part. You know, they're almost equal. I can compare them to each other, but I can also compare them to the whole thing. I can say, well, you know, track is almost 1/4 of you know, what everybody plays in terms of sports. The next one is the bar graph. This is comparing amounts of things. So here I'm actually like counting things. I went out and I counted who, you know, what everybody's opinion is about the nicest fruit. And so that I've got my fruits at the bottom. Over here on the line graph, it's going to always be change over time. So here at the bottom, I have my years. And I can barely read what they're trying to measure there, but line graphs are always going to be change over time. Again, pie graphs are for percentages and comparing parts to each other and to the whole. Bar graphs are for comparing amounts, and then line graphs are for comparing a change over time.